Impacts and Collisions 2017, question 5a. A small smooth sphere A of mass 1.5 kilos moving with speed 6 meters per second collides directly with a small smooth sphere B of mass m kilos, which is at rest. After the collision, the spheres move in opposite directions with speeds v and 2v respectively. 80% of the kinetic energy lost by A as a result of the collision is transferred to B, and the coefficient of restitution between the spheres is E. Find the value of V and the value of E. Okay, well, let's start here with the principle of conservation of momentum. One of them is at rest. So we have mu1 plus mu2 is equal to mv1. We're asked to find V plus mv2. So the first mass is 1.5 and it's traveling at 6. The second mass is m and it's traveling at 0, it's at rest. So that's equal to 1.5. And we're told here to travel in opposite directions. So the speed after the impact, which is my second velocity, these two, well, the 1.5 must go back, it's minus v and plus m times 2v. So we get 9 is equal to minus 1.5v plus 2mv. So we've got two variables, m and v. So we're looking for v, so why don't we get what m is equal to? So 9 plus 1.5v is equal to 2mv. So m is equal to 9 plus 1.5v divided by 2v. Then we're told that 80% of the kinetic energy lost by A as a result of the collision is transferred to B. Okay, well, kinetic energy is a half mv squared. So what's B's kinetic energy? This is what it gets 80% of A's, but B's is a half m by 2v to b squared, which is equal to a half m by 4v squared. So 2mv squared is the kinetic energy that B has. So let's see what 80% of the loss of A is, and then these two things are going to be equal. So 80%, so we're going to get 80%, 0.8 of the kinetic energy lost by A. So it's a half mv squared initially, a half 1.5, and 6 was the speed initially. And we don't know the speed afterwards, we don't know this v. So a half m by v squared, that's 80% of the kinetic energy lost by A. So we simplify this down, we're going to get 0.8 by 36 by 1.5 divided by 2 is 18 by 1.5, which is 27, minus 1 over 2 by 3 over 2 is going to be 3 over 4 v squared. And this would have to be equal to this guy here, the kinetic energy of V. So can we simplify that? We can simplify that down even further. Okay, 0.8 by 27 is 21.6, and 0.8 by 3 over 4 is 0.6, and that has to be equal to 2 mv squared. Now we have m, I should have probably simplified this 2mv squared first. 2 by 9 plus 1.5v over 2v, that's 2m by v squared. So we're going to get 18 plus 3v over 2, 18 plus 3v over 2v by v squared. So I can divide by v to get rid of the squared, and I'm going to be left with 18 plus 18v plus 3v squared over 2, which is 9v plus 1.5v squared. Okay, so I'm going to get 21.6 minus 0.6v squared is equal to 9v plus 1.5v squared. So it's going to be a quadratic, so we're going to get 2.1v squared. 2.1v squared, we're going to the right, so it's plus 9v minus 21.6 is equal to 0. Does anything divide into all of these? It doesn't look like it. So we can see from the quadratic I'm going to have one negative value with the plus and the minus. The positive value I get is 1.7143 ms to the minus 1. So that's v. What were we asked to find? Value of v and the value of e. Okay, let's look at the value of e. So we have v1 minus v2 over u1 minus u2 is equal to minus e. So my v1 was minus v, and then we had a minus 2v. Just let's double check that. I'm doubting myself. The velocities, yeah, v, and it was going, it was a negative v, it was going in the opposite direction. So v and 2v. And u1 was the 6, wasn't it? Jumping up and down here, the 6. And at rest is 0. So we had a 6 minus 0 is equal to minus e. So minus 3v equals minus 6e. 3v is 6e, and we got, what do we get for v? 1.7143 divided by 6 will give me e. Which gives me a value of 0.857. E is equal to 0.857. That was the only part, that was all we were asking, part A.